I have with me a little plastic box. I'm going to pass it around so you can all have a look and a feel of it. And so you can have a little play while I'm talking. So you can see what it is that I'm talking about, because this is what it is. It's a device called the Raspberry Pi, and I'm going to tell you what it is and what it has to do with education. Right, here's a question. This is a photo. Does anyone recognize this photo, first of all?
Yeah.
Jesse does. What is it, Jess?
That's Steve and Wozniak.
Steve Jobs and Steve Wozniak. And they're building the Apple I, the first Apple computer that they sold. Now I'm going to say that looks quite a lot more technical than the average computer science student today, who is sitting there at a computer, probably using Visual Basic or maybe designing HTML code. So what has happened to this sort of scene? And if we put that in a bit of a mood board, what I'm trying to show here is the devolution of student programming, of hobbyist programming as well. On the left, this is an original Apple I broken in pieces. This is Steve and Steve. That is the Spectrum ZX. If you see, it saves things on a cassette tape. Likewise, there's another cassette tape disk drive here. And here we have what used to be a phone modem. Before they had ADSL and dial-up modems, you literally picked up the receiver off your telephone and you would dial up the other computer and they would communicate, and it was a lot more technical. The real nail in the coffin was the multimedia PC, which brought Encarta to the home, along with a whole load of mollycoddled, watered-down Microsoft-type computing. And then, of course, now every kid in the world plays Xbox or has the iPad do it for them. So we've had a bit of a downward trend. My font seems to have gotten a bit mixed up, but asks the question, has electronics gone beyond the common man or woman? Back in the 70s, we had Steve and Steve, and now we have people, their idea of computing is doing something on Photoshop. I've lost another of my fonts. This isn't right. Anyway, yeah. Aben says no. Aben is a academic at the University of Cambridge who has been putting together and leading the Raspberry Pi project. He's been doing Movember as well. Hence he's got a pretty funky mustache. But this is the Raspberry Pi, and this is what you're looking at now. It's a credit card sized motherboard, and it's got all the outputs of a typical computer. Because it's modern, it uses HDMI, but the most exciting part about it is over here. The GPIO pins. If you got it now, you might notice that there's some pins on the other side. And what you can do is you can start connecting those to breadboards and electronic components, and you can start wiring up robotics and lighting systems, and you can do all sorts with it. And an example of it in use would be here. You see it's sat next to an iPhone, which gives you a gauge of the size of it, and it's all connected up, and that's what I was hoping to have done today, but unfortunately our equipment set up in the university isn't quite compatible yet. And these are a few of the projects that have been done with it as an idea. Somebody's made a mini arcade game, and somebody else. Now bear in mind that Lego is completely open source. Somebody has racked 64 of them together and made a supercomputer. So there is this is far more creative than a fancy little budget computer. This is a motherboard for coding robotics, for creating new ideas and new inventions. Okay, so where does that sit with psychology? If you read my blog this week, you will have seen that I've come up with 5 principles that I consider universal to higher learning. Now let's look at where the activities on the Pi sits with those, and I'm going to show you some examples of what students, these are actual students, not homebrew computerists, have done in a second. I think it really sits with semantic encoding, a depth of elaboration and a real understanding, an applied understanding of material. And I think that empowerment social networks, intrinsic motivation, and metacognition all contribute to that rich collaborative experience. So, you give somebody a Raspberry Pi. By the way, I forgot to mention how much it costs. Any guesses? And if you know, no answers, you're not allowed to say. So Matthew and Jess, you're both out.
It must not be very much if you're going to give them to us.
Well, that's a good point, isn't it? How much does an iPad cost? £400. How much does a Raspberry Pi cost? £25. So you can give a student this and you can empower them to start creating for themselves for real, not in theory. I think that's pretty much intrinsic motivation. You're not doing this because somebody else is telling you to do this. There's some real mastery learning when it comes to programming. Likewise, you don't want to do this on your own, do you? You want to do this with your mates. So it's a social learning experience. You've got a real, what's the word? Serendipity about coming up with your ideas. And metacognition, I don't think applies so much to coding, unless someone can prove me otherwise. So, what has been done with it? This is a classroom where this teacher, I've forgotten her name, but she has been working with the Raspberry Pi team to develop some open source curriculums wherein the students are synthesizing music. They're not just playing on a keyboard or using GarageBand or whatever, they are coding the sound waves and making their own synthesized sounds for real. This is what's called the Leica board, and it actually, strangely, it plugs in through the USB, but it's the same principle. It allows the students to start switching on lights, using robotics, turning on switches, making mechanical things happen, which you can do all sorts of things with. You could start making electronic clocks, I've seen done with it, and I'll show you something else in a second that has been done on the same principle. But look at this picture here, okay? That is what I call a student-led social learning space. You saw the photograph in the last slide of Dan's, when we had all the uniform computers all clicking on the right thing at the same time. I think this is where we need to be as we move away from this stack it high, sell it cheap education. This is the coolest thing I've seen done with it. High altitude ballooning. Okay. What these students did was they attached a GPS and some temperature sensors and a camera to the Raspberry Pi, again through the GPIO slots, and they attached it to a weather balloon and sent it up 31 kilometers in the air into near space. This is the photograph that was taken on the Raspberry Pi, and this was A-level students. So I think you're really empowering people to follow their interests and do what excites them. It got to minus 34 degrees up in space and the Pi was still running. Okay, I don't know if anyone's ever done the first Lego League. I did when I was 9. We came second to Benton Park. But they beat us. I suppose they're the better men. But now they are operating Lego robots with the Raspberry Pi. Coding it again and designing robotics, and it's a miniature representation maybe of real life, but it is every bit real in terms of what they're doing and the experience that they're having. What about less economically developed countries? Well, it's powered off a mobile phone charger. It's low power. Now this is a setup that they did in Africa. They turned a classroom into a Raspberry Pi computer lab. The electricity did come from charitable donations and still does, but it's low power, it's easy to set up. And it can even be solar powered because it's such a low power rating. So it's a real answer rather than donating tons of expensive equipment that is really primarily designed for a more Western curriculum. And last of all, MOOCs. Because of the open source nature of the Raspberry Pi and the coding and the different projects, anybody is empowered to start putting things together for it. Now, I've heard us talk a number of times about iPads and things like that in education. The iPad is a fantastic product. It is connected, it delivers a rich social learning experience, but it costs £400. And the reason why we don't use, say, the Kindle Fire or some intermediary Android tablet is because the development just isn't the same. On the other hand, the open source community is really empowered and has really put together some fantastic tools. This is the first MOOC that has been done to get people using the Raspberry Pi. Unfortunately, it's in Spanish. I don't know if anyone else can read that. I can't. But it's where it's going. So, I'm going to show one more video, okay? And this just demonstrates how the Pi has been used in schools, or can be used in schools.
These days, knowing how to code is like having a superpower. You can make almost anything you can dream up. But there still isn't a simple place for new coders to get started building cool, real stuff for the web. Maybe you've heard about Raspberry Pi. It's a little machine that helps teach kids how computers work. We got to thinking, Raspberry Pi could be great for teaching how the web works too. So we built something for Raspberry Pi called Coder. Download it, put it on an SD card, plug it in, and it turns your Raspberry Pi into a simple place to write code and a mini web server to run it on. Everything you need to get started making real web things using the real languages of the web. It's also a simple, cheap way to get a server into a safe learning environment, like a classroom or living room. Coder is open source because we know there are tons of different ways of teaching and learning, so everyone, including you, can help make it better. This is just the beginning, a little download for everyone to get started.
So I hope that just gives you a perspective and maybe a bite-sized chunk of how this can really empower the students to do real computing things in the laboratory setting of the classroom and the home.
I have a question.
Okay.
First.
Okay.
It was announced this morning on Sky News
Yeah.
that Amazon, by I think they said 2015, will be delivering parcels via a drone. What's your opinion on that?
I used to live in Germany, and I went to a hospital one time wherein there was a drone that was delivering medical equipment across the hospital, and it could open the doors, it could go into the lifts, and all it did was move along at a very slow pace, shouting in German, "Watch out, I'm coming," and it had some flashing lights on it. So I think the technology exists. If you can navigate something around a hospital and with these driverless cars, it's possible.
This is what Amazon are announcing. This is what they think is going to happen in the future.
I don't think we should close ourselves off to things just on principles of health and safety, but if we can make it safe and make it work, I say why not? Okay, Matthew.
You're on about implementing this into the sort of school curriculum. How would it be implemented? Would it actually have a lesson of its own? Do you think things like this are replacing things like lessons like woodwork and metalwork and stuff?
I'll tell you this, the computer science module, there has been a computer science module that is being integrated into the EBAC, the English Baccalaureate, and Google has been working with the people who design the syllabuses and with organisations such as Teach First to make a Raspberry Pi based curriculum. They've donated about 15,000 of these machines to the to educational causes, and there are already schools across the nation which are using this in their computer science class, both at GCSE and A level. No, not at all. I think those trades are just as valuable, but I do think this is replacing the kind of IT lessons that we would have done in school, where we'd sit and learn to use Microsoft Word, or maybe do a bit of Visual Basic programming. I think that's where it's going to come in.
In some way, though, for kids, do they not need to learn the basics of, if you literally just went straight into that, which, to be quite honest, confuses me a lot, it looks very scary, you might get a generation where kids can do all this fancy stuff, they can code things, but they don't know how just to do the basics?
Ask what basics we're talking about. Are we talking about IT, like operation of computers?
If they're not doing it at home, they may not sort of know how to surf the web, how to use Google Scholar the best. They just might not know the basic skills.
Well, I would say, I don't know if you've seen the TED Talk by Sugata Mitra. Now, for better or for worse, he does demonstrate that kids in the digital native sort of generation are remarkably adept at being able to get on the internet and answer their questions when they want to. to learn to use Microsoft Word. And I think there's a kind of a nature within the coding environment that if you don't know the answer, you Google it. And so I think it's all integrated.
Do you actually think this is the basic structure? Do you think we've actually missed a step, obviously going to programs like Microsoft Word and things without realising how they actually work?
I think we have. There was once upon a time where if you wanted a program, you made it. Now, when my dad did his A-level in computing, what they did was they wrote their program and they punched holes in paper, and then they fed that through to the Leeds City Council, who had the only computer in the city, via this telephone modem that you saw. And a week later, they would get an output from their program. Now, that is program on its bare elementary level, but yeah, I think that while Microsoft Word is great for the admin assistants, in fact, it's great for the professions, it isn't real computing. And by empowering people in this way again, we can have people back like the two Steves who said, well, we have an idea for a computer that can change the world. And they made it. The Apple I was produced by Steve Jobs and his family in a garage in California. So, thank you.